Hello everyone, and welcome to part 2 of Geometry Lesson 4.2, Isosceles and Equilateral Triangles. Let's take a look at another theorem about isosceles triangles. Theorem 4.2 does not have a specific name, so we can't use a name to describe it. If you needed to use it in a proof, you would just write the fact. It says, if a line or line segment bisects the vertex of an isosceles triangle. So that means that this side of the angle is equal to this side of the angle. And I know this big outer triangle is isosceles because AB is congruent to BC. So if all of that is true, then I know that BD is also the perpendicular bisector of that opposite side. So BD is going to be perpendicular to AC, and it's also going to make AD congruent to DC. So if I know that this is equal to this, and this is equal to this, then I also know that this is a right angle here, and I also know that this side is equal to this side. So we're going to look at some applications of this. In example 4, it says, a prefabricated house is delivered to a foundation in 2 symmetric halves that are assembled on site. Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? Explain. So in the picture, we need the total height of the house because this house is just going to be on a truck bed. So I know that this height from the base of the house up to C is 10 feet, but I need to know the height of this part right here, BD. So I need that height. Now I also know that this side is equal to this side, so AB is equal to BC, making this big outer triangle isosceles. And I also know that this angle is equal to this angle. So this means that that theorem that we just talked about applies. BD is the perpendicular bisector of AC. So this angle is right, and this angle is right. And we need to find the side lengths of a right triangle. And anytime you need to do that, think about Pythagorean theorem. So let's see how that's going to apply. Now in the picture, it looks like we only have one side of our triangle, the hypotenuse. But we can figure out AD and DC because I know that this total length is 28. And if this length is 28, this one is also going to be 28. So I know AD is 14 and DC is 14 because the 28 is bisected or cut in half. And half of 28 is 14. Now we put it into the Pythagorean theorem. I know that 14 squared plus the height of the triangle squared is going to equal 16 squared. And now we're just going to solve for x. I squared 14 and squared 16. I subtracted the 196 from 256 to get 60. And then I did a square root on both sides. So I know the height of BD is the square root of 60, which is 7.74. But I still need the total height of the house. So I have to add this to the 10 feet that I already knew. And 7.74 plus 10 is 17.74 feet. This is too tall for the 17 feet that they had, so they need a different route. Let's take a look at another example where we apply this property. In Try It 4, they ask you to use the picture to find the measure of angle RSQ and also to find the length of PR. So pause this video and try it and then hit play to see if you're right. When I looked at the picture, I noticed that this big outside triangle is isosceles because this side is equal to this side. And because it's isosceles, I know that this 31 degrees is going to be equal to this angle over here. And that's also 31. Then I noticed that this angle is bisected, which means that SQ is the perpendicular bisector of PR. And because it's perpendicular, then I know that this triangle over here is a right triangle. So this is 90 degrees. So all I have to do is use the triangle sum theorem and do 180 minus 31 plus 90, which got me 59 degrees. And that's the measurement of angle RSQ. In part B, it says, what is the length of PR? Now, we already established that SQ is the perpendicular bisector of PR. We figured that out in part 1. So what I'm going to do is look at the side length, and I notice that QR is 4, so that means PQ is 4, and the total length is 4 plus 4, which is 8. Let's take a look at another theorem related to this. This is a corollary to theorem 4.1. Now, theorem 4.1 was the Isosceles triangle theorem. A corollary is a fact that follows from that, something that because one theorem is true, this just makes sense because of it. And the corollary says a triangle is equilateral if and only if it is also equiangular. Okay, so if you know it's equilateral, it's going to be equiangular. If you know it's equiangular, it's going to be equilateral because this is a biconditional statement. So let's take a look at the proof and how we can figure it out based on theorem 4.1, which is the isosceles triangle theorem. It's given that all three sides are congruent. We need to prove that all three angles are congruent. Now remember, it's based on that theorem, so let's take a look at the steps. I always start with my given statement. Then I notice that the isosceles triangle theorem would say that angle E has to be congruent to angle D, and angle F has to be congruent to angle D. And all I did was I just took a pair of sides and I looked across from them and I found the two angles that were across and I wrote them as being congruent. Then I took another pair of sides and I wrote the two angles that were across from them and I wrote that they were congruent. So that's the isosceles triangle theorem. Then I just used the transitive property of congruence to say if D is congruent to F and D is congruent to E, then all three angles are going to be congruent. And that's my proof. Let's look at some examples where we apply this fact. In example 6a, it says if angle CBD, so CBD is this bigger angle here, is 130 degrees, what is the measurement of angle BAD? So that's this smaller angle right here. Now, I notice all these congruent symbols. I know that ABC has three congruent sides. That means all three angles are congruent, and that means they're also going to be 60 degrees. So I know that this angle is 60 degrees. So all I need to do is subtract to find out the measure of the angle that's right here. Now I know that's not the angle we want, but it will get us closer to what we need. I did 130 minus 60 to get 70. So now I know that angle ABD is 70 degrees. Now I can apply what we learned at the beginning of our lesson. If this is 70, I can do 180 minus 70 to get what these two add to. And these two have to be equal, so I just have to divide by 2. 180 minus 70 is 110, so these two add to 110. And I know both of these angles are equal, so I can just do 110 divided by 2 to get 35. So angle BAD is 35 degrees. So pause this video and try part B, and then hit play to see if you're right. In part B, they wanted to know what is the measure of angle U, which is this angle over here. Now they only gave us the 72 degrees over here. But I did notice that this triangle is isosceles. So what I did is 180 minus 72 to get 108. Angle T, STV, and SVT are equal, so I could divide by 2 to find SVT. So I got 54 for that. Then I noticed that this angle is an exterior angle to this triangle. And I know the exterior angle theorem says that this one plus this one are going to equal this one. So 54 is this angle plus this angle. And I also happen to know that this is an isosceles triangle. So these two angles are going to be equal. So I just had to divide by 2. 54 divided by 2 is 27. And that's my final answer. Let's do one more example of this. In Try It 6, it asks you to find each measure. In Part A, they want angle PNO. PNO is this angle right here. And in Part B, they want angle NOP. NOP is this angle right here. So pause the video and try it, and then hit play to see if you're right. For angle PNO, what I did is I knew that this triangle is equilateral. So MNP, this angle right here is 60 degrees, and MNO is 180 because it makes a straight line. So all I had to do is 180 minus 60 to get this angle, which was 120 degrees. In Part B, I used the 120 degrees that I just figured out to find my missing measurement. I know that this is a triangle, so I have to do 180 minus 120, which is 60. And that's going to be the sum of this angle plus this angle. And I know these two angles are congruent because this is isosceles because of these two tick marks. So all I had to do is 60 divided by 2 to get 30. And that's the measure of the angle that I needed. That's it for this lesson. Please make sure you've taken notes and let me know if you have any questions.